Day 12. Today we're going to talk about factoring. We're going to talk about factoring using GCFs, factoring quadratics when your first term is 1. And then we're going to talk about factoring quadratics and GCFs together. Then finally, factoring quadratics when your x term is greater than 1. Your coefficient for your x squared term is greater than 1. We're going to do it the magic way. There's at least 4 different ways to do it. We're going to do it exactly one way, and I'm going to show you that. And then we're going to do some. But mostly today is just examples. That's all you wanted. So we're going to do a lot of examples. I have lots of examples set up for you. And so let's get at them. So we're going to talk today, as I said, about factoring using GCF, factoring quadratics where your a term is equal to 1. Those are like x squared plus, 3x plus 2. Then we're going to do factoring quadratics GCF first. So we're going to combine. This, combines 1 and 2. And then we're going to factor quadratics a is greater than 1. These are going to be ones like, 2x squared minus 5x minus 12. Where I'll show you how to do this. The easiest way I've heard, there's like 4 different ways. There's 4 ways of doing this. But I'm going to show you the easiest way I've seen. And it really hopefully works for you. All right. So let's move on. Let's do these examples that we're talking about. All right. First of all, let's talk about factoring just using GCFs. So in this case, we see 2 terms. We're going to find the GCF, and then we're going to, pull it out, and have, and have leftovers. This is how I like to describe it. We'll just kind of get rid of this right now. Okay, so let's do our work in. Let's just do some work in maybe green here. Here we go. So our GCF here is, if we do our old school way of doing this, it would be 2 times 5 times x times y, and here we have -1 times 2 times 3 times 3. Times y. So our GCF is 2y, right? So it's 2y. And then our leftovers on top is 5x. And on bottom, it's in GCF is 2y. And then on bottom, we have -9 on the bottom. So our factoring here would be our 2y times 5x minus 9. And the way that's, what is factoring? It's the reverse of distribution. So we can check by distributing our terms back, saying, yeah, 2y times 5x is 10xy, 2y times 9 is minus 18y. And so that's our check step. Now, I know some of you know how to find GCFs a lot faster, so we'll just go ahead and write that out. If you know how to do it faster, you can do it that way. If you like to go the old way where we build our chart here, that's fine too. The chart you'll never screw it up, or rarely screw it up. When you try to guess your GCF shorthand, you sometimes screw it up, but I'll leave you to your own devices. So this GCF is 3ab squared. So our answer is 3ab squared. Now remember, our answer is 1. Whenever we take our whole GCF out of a number, we have to leave a 1 here. And it's plus 7a squared b. And you can check your answer. I encourage you always to check your answer by multiplying back. And so you get 3ab squared plus 21a cubed b cubed. Check. Here, our GCF is 5xy. Leftovers are 3 minus 8x plus 5x squared. Check is 15xy minus 40x squared y plus 25x cubed y. Here, down here, our GCF is 4abc times a minus 2b plus 3c. And our check step all is good. I'm checking my work here. Everything looks dandy. And we have to box our answers. And GCF is 5xy. GCF is 4abc. I really, really like showing all my work. Really appreciate that. All right, let's move on. Okay, now we're going to do factoring quadratics a equals 1. So the idea here is we got to find a number. You know, they add to 7, and then they add to positive 7, and then they multiply to positive 12. So what two numbers add to 7 and multiply to 12? Well, that would be 3 and 4. So we get a positive 3 and positive 4, x plus 3, x plus 4. I sometimes like to see it like this, plus 7. You know, that's my plus, and then plus 12. And then I find two numbers that add to this and multiply to this, and I write plus 3, plus 4. That's one way to do it. Another way to do it, some people like to write charts, and they write what does it add to and what does it multiply to. It adds to 7 and it multiplies to 12. So this has to be two positive numbers. So we find numbers that multiply to 12, 1 and 12. They don't add to 7. You know, 2 and 6 multiply to 7. They don't add to 7. But 3 and 4 multiply to 12 and add to 7. So there's at least three different ways of doing this. B, x minus 4, x plus 1. Choose your poison. How do you do that? This one's interesting. We have to find numbers. You got to think of this like x squared plus 0x minus 25. This is also a special pattern. We haven't talked about those yet, but if you don't know the special patterns, you can still look at it this way. You need two numbers that add to 0 and then multiply to negative 25. Well, all numbers that add to 0 are additive inverses of each other. So what numbers multiply to 25? Well, that would be plus 5 and minus 5. And here, we need numbers that add to positive 6 and multiply to positive 9. And that would be x plus 3 times x plus 3, or simply x plus 3 squared. Okay, there's my examples, a equals 1. Now we're going to move on, factoring quadratics a equals 1, where we get these big numbers. Now we got to find numbers that add to 1. They add to 1, but they multiply to negative 132. And sometimes we have a hard time figuring out these kinds of numbers. So numbers that add to 1 and multiply to negative 132, that has to be a positive number and a negative number. A positive and a negative that multiply, and the positive that they've got to multiply to negative 132. So we got to find all factors. I'm going to show you the long way of doing this. So 132 is, well, what's that? That's 2 times 66. Well, that's 6 times 11, and that's 2 times 3. So I have these numbers that multiply to 132. 2, 2, 3, and 11. These are going to help me find all of my numbers that multiply to 132. So I could take 2 times this would multiply to 132. Or I could take 4 times this to multiply to 132. Or I could take these two numbers times these two numbers. And all of those will give me 132 because these are my factors of 132. So I need to find numbers that add to 1. So that's going to be a bigger positive number and a smaller negative. Well, let's try that. So let's look at this. So my small number will be the negative number. My big has to be the positive. So we'll start with negative 2. And then what is this? This is 66. That's positive. Well, that's not 1. I got to get way closer. So I could try minus 3 and then 44. That doesn't work. I could try minus 4, right? Minus 4. But these aren't going to work because they're not big enough. So I got to try maybe 3 times 2 times 2. That would be negative 12. Nope, but my number's got to be, negative number's got to be smaller. So I'll do negative 11 and then positive that, which is positive 12. All right, good. I found my number. Right, positive this and minus this. So my answer is x plus 12 and x minus 11. Okay, I'm going through these fast because all you want is the examples. Similarly here, how do we find this? Well, 72 is 9 times 8. That's 3 times 3. And this is 4 times 2. And that's 2 times 2. Now, I need two numbers that add to 6 and multiply to negative 72. Well, that's going to be a big positive and a smaller negative. Okay, so let's see. I have 3, 3, 2, 2, 2. So let's try all my 2's is negative, would be negative 8, and 3 times 3 is my big positive. Well, that's not good enough. I need a number that's bigger than 9. Well, let's try maybe 2 times 2. Let's try these ones. 2 times 2 times 3. Well, 2 times 2 times 3 is, that's my 12. So then I've used those 3, and then I get minus 6. Well, do those add to 6? Yes, these add to 6. So I have my answer, x plus 12, x minus 6. Here we go again. Now I need a big negative and a smaller positive. Why? Because they have to add to a negative number. So my negative number is bigger. So let's see, 60 is 4 and 15, 2 and 2, 3 and 5. So here's my factors. So, well, let's try 15 and 4. Negative 15 and positive 4. Well, that doesn't work because that's negative 11. I need a bigger negative. So maybe I'll go 5 times 2 times 2. Well, that's negative 20. Left over 3. Yeah, that gives me negative 17. So I've now figured it out. So that's x minus 20, x plus 3. Good. All right. Now let's move on. Now we got to factor. I'm giving you a hint. We got to do GCF first. So always, when factoring quadratics, always look first to factor GCF. Always do your GCF first, then do your quadratic. Do not do your quadratic first. It's going to be way easier. So here I can see, what do I see? I see that everything divides by 3. So my GCF here, and this only has a 3 term, so I know that there's no variables in my GCF because this no variable goes into this one. So my GCF is 3. So then I say, well, I'm at 3x squared minus 2x plus 1. Now I got to find two numbers that add to negative 2 and multiply to 1. Well, that's negative 1 and negative 1. 3 times x minus 1 times x minus 1. Right? This is negative 1 and negative 1. And that's 3 times x minus 1 squared. Here my GCF is a little bigger. I have an a and a b term everywhere, and I got 5. So my GCF here is 5ab times a squared plus 4a plus 3. Well, what numbers add to 4? They add to positive 4 and multiply to positive 3. Well, that's 3 and 1 positive. So that's 5ab times a plus 1 times a plus 3. Getting it? All right, C. Well, clearly on this one, we get at least a 7, but we also have x squareds in each one of these. So our GCF is 7x squared. So we get 7x squared times x squared minus x minus 20. And our numbers that add to negative 1 and multiply to negative 20, well, that's a negative 5 and a positive 4. So our answer is 7x squared times x minus 5 times x plus 4. And now our final piece And I'm going to teach this one to you, so if you're totally bored or you totally get it, you don't have to sit here and listen to this, but at least pause and try this one here. So when we have an a greater than 1, there's a lot of ways to solve this. And I'm going to show you this kind of magic jujitsu way to solve this one. And the way that you do it is you multiply your a and c terms, your a term and your c term, and then you put that and make a c term out of it. So watch this. So now I'm going to say, well, that's x squared. I'm going to take my a and multiply it by my c and remove it. So that's x squared minus 5x minus 24. Now, these are not equal. They're not equal. I'm just doing some magic and doing some transformation to help you find the answer. So now we know how to factor this. This is just x minus 8 times x plus 3. Okay? We know how to do that, and if you don't know how, go refer back to some of the previous slides. Okay, now what you do, so that's step 1 and step 2. Now the next thing we do is we divide the second terms here back by our original 2. So watch that. So we go x minus 8 over 2 and x plus 3 over 2. So now we've done step number 3. This is step 3, this was step 2, this was step 1. Now we simplify our fractions. This is step 4. So we say x minus 4, and this one's already simplified, x plus 3 halves. Now, if there's any fractions left, you move the denominators to the front of the first terms. So this one doesn't have any fractions, so we go x minus 4. And this one does, so we take that 2 and we move it in front of the x like this. 2x plus 3. And magic, you have the answer. It's unbelievable that this works, but it indeed does work. It works every single time. I learned this year. I've been factoring for 30 years, and I learned this trick this year. Now, these things are not equal. This isn't like an equality working its way down. But if you follow the steps, it does work. And I actually proved that this works, but it's kind of very involved proof to prove that this works. So I'm not going to do that for you. So let's go and do one more the same way. So again, what are we going to do? Let's go ahead and copy our steps just so we see them as we do them one more time. Let's just copy all of these steps, so you can see them. Okay, step number 1, we multiply these terms. And so we get, and we multiply these terms, and we move those to the end. And so we get a squared, this is step 1, a squared minus 7a minus 120. Well, now we got to find numbers that multiply to negative 120 and they add to negative 7. Well, that's going to be a big negative and a small positive. So 120 breaks out into 12 and 10, 2 and 6, 2 and 3, 2 and 3, 2 and 5. So my factors are 2, 2, 2, 3, 5. The negative's bigger, so let's try, let me just try these ones and these ones. The smallest, the positive, negative 15. Oh, well, I got it right off the bat. Okay, good. So now I know that this is 8a minus 15. A minus 15 and a plus 8. Right? Okay, and now I get to divide by that original 12 here. So that's step 2. Step 3, we divide by our 12, a minus 15 over 12, and a plus 8 over 12. So now we simplify each fraction. That's step 4, a minus 5 over 4, and a plus 2 over 3. And now step 5 is we just fix our fractions. So that's by putting our denominator and then moving that term in front of our variable. So 4a minus 5 and 3a plus 2. And magic trick, we are done. And we can check our work if we want to. 3a times 12a squared is 4a is 12a squared. 2 times 8 is plus 8a. 5 times negative, and 3 times negative 5 is negative 15a. And then 2 times negative 5 is minus 10. We combine terms and we get 12a squared minus 7a minus 10. Unbelievable magic that it works. All right, and we are now out of here. We have just